Hello everyone, so here comes the final review. We have learned 5 more chapters in the second half of the semester. So I'll start with the chapter 6 and we'll talk about the most important things that you need to know for the chapter. So before that, for the final exam, I think the most important 2 things are first is your assignment, or you have to know everything about your assignment. And so the final exam will be very similar to the assignment questions. And the second is the examples in the lecture notes. Right, so those are the questions that you need to review. And for chapter 6, first we talk about the introduction part, which is the rate of change. Right, and then from the rate of change, we talked talk about the limit, and we say that the limit of the rate of change is called the derivative, right? So what you need to know is to know how to calculate the derivatives, right? So I think, but first you need to know what is the left side limit and right side limit, right? So, and then specifically you need to know the 4 graphs. So if this is a continuous function, then at the point n, the right-hand side limit, or we call the left side limit equals to the right side limit, right? Because it's continuous. But if it's not continuous like this, in this graph, right, there's a jump from the left side of n to the right side of n. So the left side limit of n is not equal to the right side limit of n. So in the final, I may ask you to find the left side limit and right side limit given a function. And you need to know whether or not it is continuous or discontinuous at certain points. But it shouldn't be so hard. I mean, you should be able to draw the function on the plane, right? It should be some easy question, an easy function for you to draw, and not some very crazy ones. So you need to know whether or not there's a discontinuous point on the graph, right? So for the first graph, for the fourth graph here, it's not continuous at the point n, right? Because the left side limit is negative infinite, and the right side limit is positive infinite, right? So just pay attention to these cases when there's a discontinuous point. And then you need to know the 2 examples, right? So how to find out the limitation. So specifically when the denominator here is 0, right? So when you just plug in v equals to 1 to the denominator, you find that it's equal to 0, right? So you need to transform the q function into something that you can evaluate, right? So in this example, we just transform the 1 minus v squared into the summation of 2 parts, 1 plus v times 1 minus v, right? So this comes just a review, right? A squared, plus, it's not easy to write. A squared plus b squared. Anyway, I'll just talk about that. So a squared plus b squared, a squared minus b squared equals to a plus b times a minus b, right? So this is the equation we use. So using that formula, again, a squared minus b squared equals to a plus b times a minus b, right? Using that formula, we can divide the 1 minus v squared into 2 parts. Then we can cancel that, and then we can find, okay, the q function is just 1 plus v, right? So now we can plug in v equals to 1 to the function and find that the limit is actually 2. So next time when you see that if you plug in directly um, the number to the denominator, maybe it becomes 0, right? So if the denominator is 0 and you cannot analyze the things like that, then you need to think of a way to transform, right? Or to think of a way to just to change the function to something that you can evaluate. Okay, and here comes some of the limit theorems, and you need to know, right? Okay, and this is chapter 6. And for chapter 7, we continue talking about the differentiation. I mean, from chapter 6 to chapter 12, everything is about differentiation, right? So that's the most important thing you need to know. So for chapter 7, we talked a lot of rules, right? So that's a very basic thing that you need to know in order to compute the first order derivative. And of course, second order derivative, right? In order to compute the derivative, you need to know all the kind of rules. Okay. So this is about two functions, right? The sum difference rule and the product rule and the quotient rule, right? So these are very basic things. And you have the formula here, so you don't need to remember anything, recite anything. Just need to follow the formula, and you should be able to find the answer. Okay, and the chain rule is also important, right? So for example here, if I tell you that z is a function of y, then y is a function of x, then you should be able to find the derivative of dz over dx, right, by using the chain rule to first find the derivative of z over y and then y over x, right? So this is just everything about the chain rule, everything about that. It's just this example. If you know how to find out the answer from the example, then you know everything about the chain rule. Okay, so here comes the inverse function. The inverse function is just everything about this formula, right? Okay, and partial differentiation is also important. You need to know how to calculate the partial differentiation. Well, the rule of the partial differentiation is just when you calculate, for example, partial y over partial x1, then you consider all the other variables to be constants, right? So here we have two variables, x1 and x2. So if we take the partial differentiation with respect to x1, then you treat x2 as a constant, right? And if you take the derivative with respect to x2, then you consider x1 to be a constant. Okay, and that's it. And then for chapter 8, we talk about the total differentials, right? So first thing, you need to know how to write down the total differential of something. So here. But here you need to know one thing. So if I ask you to find out the total differential of something, you need to write down exactly this equation, right? So if you just write down like fx or fy, then it's not total differential, it's partial differential, right? It's called partial differential. For total differential, you have to write something like fx times dx plus fy times dy, the whole equation. Otherwise, you'll lose your point, right? Because the question is about total differential, so you have to write the function like this, right? Not just show me fx and fy. You need to combine them to the answer, right, of total differential to get a full credit. Okay. And then there's some basic rules of differentials that you need to know. It's just very similar to the chapter 7, the kind of rules. And the total derivative, so here is also important, right? So if I give you a function, something like this, and x is a function of w, and we need to find out the total derivative of y with respect to w. So we need to use this formula, right? So this is also important. So anyway, all the important concepts follows by some of the examples. So that's why it's important to know the examples here, right? And for the implicit functions, the most important thing is this formula here. Um, right. So this is the most important thing. So if you understand this formula, then you should be able to understand everything about the implicit function, right? So for any kind of function, if you think it's an implicit function and it asks you to find out the partial derivative, then you can use this formula to do that, right? And again, we have some of the examples here for you to refer. Okay. So for chapter 9, we talk about the optimum values and extreme values. So the first thing you need to know is what is relative and absolute extreme, right? So we use 4 graphs here to show that, okay, these 2 points, for example, are relative extreme, but the point here is the absolute maximum in the range, right? And here is the absolute minimum, right? So although there's a peak and there's a trough here, but they are not absolute extremes, right? You have to compare the end value to the relative extreme values. And then here comes the important part. You need to know what's the first derivative test, right? And what's the second derivative test, right? And then how to use the first and second derivative, especially the second derivative, right? Because it's more convenient and more popular. So you should be able to use the second and first order test to find out whether or not that point is a relative maximum or relative minimum, right? So this is everything we talk about in the class. Okay, so here we have 4 cases, right? Depending on so first you need to find out using the first derivative to find out the stationary point, right? Where the first derivative equals to 0. And then you use the second derivative. And depending on the signs of the left of the stationary point and the right of the stationary point, depending on the signs of the second derivative, you should be able to find out whether or not the point is a relative maximum or relative minimum, right? So this is everything about second derivative test. And again, we have 2 examples for you to remember, right? And then for the last chapter, the most important thing is that you need to be able to write down Lagrangian function, right? So if I give you an optimization problem, then you should be able to write down the Lagrangian function and to solve that, right? Solve that by writing down the first order condition and then solve for the parameters here. I mean, from step 1 to step 3, you need to know all of them. And then, so here are some of the examples, right? And then for the very complicated cases like here, you have a lot of variables with a lot of constraints. So in these cases, I will not ask you to solve the Lagrangian function because it takes too much time, right? But I may ask you to write down the Lagrangian function and write down the first order conditions, and that's it. And you don't need to worry more about that, right? Just like the example shows, right? We have a very complicated Lagrangian function, and you need to be able to write down all the first order conditions here. But you don't need to, you don't need to know how to solve that because it takes a lot of time, right? So if you write down the first order conditions correctly, then you should get the full points, right? So this is about chapter 12. Okay. And again, the most important thing to review is your assignments, right? Because the questions on your assignments should be very similar to the final. And also, here are a lot of the examples in the lecture notes, and they are very useful for you to review. So here are the two major sources for you to prepare for your final exam.